Hello everyone, welcome back to this channel. And as promised, I'm making a video of the Earth tunnel. If you really want to study physics in university, you probably heard of this question before. However, I promise everyone, this video is going to be different from every single video you can find on YouTube. In case you don't know what I will talk about in this video, please use the link to see the video I made before, so then you can come back with enough prior knowledge. So here, let's again assume that the Earth is a uniform solid sphere, and we are going to drill a tunnel, but not go through the center of the Earth. Instead, it is going to make an angle with the diameter of the Earth. Assuming that the tunnel is straight and is smooth, we are going to calculate the time taken for an object to travel from one end to the other end. So from the previous video, we know that the gravitational force F is going to equal to 4 pi over 3 g rho m r. Before moving further into the question, I'd like to explain what each letter means in the formula. F is just the gravitational force. 4 pi over 3 is just a constant that comes from the volume of a sphere. G is the gravitational constant, rho is the density of the Earth, which here is taken as the density of rock. M is the mass of the object that travels in the tunnel, and R is the distance between the object and the center of the Earth. We are looking at the particle that travels in the tunnel, which is a straight line. So to find the motion, we need to look at the force component in the direction of the tunnel. And let's just call that direction x. To find the force component in the x direction, we first need to find the force at any point in the tunnel. And here, we need to do a bit of work in trigonometry. First of all, I need to draw a line that joins the mass in the tunnel and the center of the Earth. And then I need to draw a normal line to the tunnel. Let's call the displacement from the center of the tunnel x. And let's call the distance between the mass and the center of the Earth r. And x and r are making an angle theta. So if we resolve the force now, we know that Fx equals to F cos theta. And the same, x equals to r cos theta. By rearranging the second equation, that's going to give us cos theta equals to x over r. By putting it back to the first equation, that's going to give Fx equals to F times x over r, which is 4 pi over 3 g rho m r times x over r. Two r's can be cancelled, which will leave us Fx equals to 4 pi over 3 g rho m x. I know that some of you may be concerned about the normal component of force, but I can assure you that it's not going to affect anything. It is going to be balanced by the normal force from the tunnel, and also the tunnel is frictionless, so the motion won't be hindered. Same as the previous video, we know that the force is actually a vector. Also, the gravitational force here is an attractive force, so it is always going to point in the opposite direction of the displacement. Therefore, it should be negative all the time. So the force equation should be written as Fx equals to minus 4 pi over 3 g rho m x. Here, you can see that force is proportional to the negative displacement. We know that this is going to generate simple harmonic motion. So now, the question becomes to find the period of the simple harmonic motion. Now, I'm going to carry out exactly what I did in the previous video. Divide m on both sides. Use the A-level formula from your formula book. Equate two formulas to find omega square. The period equals to 2 pi over omega. The time taken should be half of the period. If you do everything correctly, you should find the answer as 40 minutes, which has the same time for the straight tunnel that goes through the center. Here, I'm going to ask everyone the same question again. You may notice that it's almost the end of the video, but do you think that's the end of the question? No. You may recall that the title of this video says it is the ultimate tube in the world. But does it mean that we can abandon our public transport now? If you want to know the answer, check the next video.